Yeah, some of.
So what's the word above it?
Some of.
I just wrote the word sum of in it.
I got it.
Okay, so we're about to get on to one of the most important subjects of the semester, which is regression. And what many of the business professors in your other classes, your other four, especially the 400 level classes, said the number one thing we want them to come out of business statistics is with understanding regression forecasting, especially accounting majors. Now, one of the career jobs I had in my life was the business manager of a large private college. So I was in charge of all the business transactions in the whole business office. And one of my responsibilities, which always took a lot of time, is the 5-year forecasting, the 5-year budget. Every company does budgeting and they continuously update it so it's always 5 years ahead. Always planning 5 years ahead. And any accounting major in here, when you get in charge of an accounting office, you are literally have to plan every dollar for the next 5 years and hope that things go according to plan, and they never do. And so you keep updating the 5-year budget based on things going. But this 5-year forecast budget always starts with revenue. Your forecast for revenue, and then everything goes based on there. And this is what you use to forecast your revenue, is regression. That's why this is so important. Don't get me wrong. You're going to learn some other forecasting techniques, but this one, in my experience, has been the best in forecasting revenue based on historical information. That's what it's all about. A time series of history of information, using that history, putting more emphasis on the most recent events compared to the past, and then using that information to forecast the future. And what's nice about it is most forecasting techniques only forecast one period in the future. This one can go multiple periods in the future. You just got to continually update it. When you forecast your 5th year, for example, and as a half a year goes by, you recalculate to make sure your forecast is on there. And if it's not, you make your adjustments. Every 6 months, you make adjustments, And you add to the forecast, so you're always 5 years out. So that's where we're at, regression. But where I want to start is the correlation example. Right here. This is going to prepare you for homework, and we manually calculate. I forgot to put the formula back up there. I'm going to put the correlation formula back up there. I want to make sure. Here it is right here. I want to review it. What's going to happen right here in K8 is going to be the correlation coefficient, and it's going to be somewhere between +1 and -1, like 0.8, 0.5, 0.6. And then this one right here refers to that correlation coefficient, but I want you to see the formula. Remember, it's from Tuesday. Correlation coefficient times the square root of the degrees of freedom. However many pieces in your sample, -2. Don't forget, not -1, -2 for when it's correlation. Divided by the square root of 1 minus that correlation coefficient squared. Got to square it first, then subtract from 1, then square root it to get that denominator. So I'm letting Excel do all that work once we find the correlation coefficient. Now, to find the p-value, it's the same dist that we've been using the whole semester. What you're going to put in there is going to be the correlation, the test statistic. Now, what you're going to notice, look at what I did to the formula for dist on this. Anybody see what I got added to it that we haven't really used this whole semester? ABS, absolute value. That's the only way you can automatically then make sure that the negative gets dropped if your test statistic ends up being a negative. Once I put in that correlation coefficient, it's going to automatically calculate my test statistic, going to calculate my p-values, but if my test statistic ended up being a negative, it wouldn't, using dist, we'd have to use one of the other ones. So instead, I just added absolute value there, so we'll turn it into a positive and calculate it the way it's been going the whole semester. Here's the deal. You've got 2 sets of data. We're looking to see if there's some kind of relationship between it. I want you to tell me, based on a look at it, remember, a relationship is that if one piece of data is going in a direction, the other piece of data may be going in the same direction or the opposite direction, but kind of in line with each other. So if you look at X, and by the way, hang on, I won't even get there yet. I want you to look at X, and I want you to look at Y, and look at each of them, and as you go from one period to the next, do they look like they could be in line with each other? Is one getting smaller while the other's getting bigger? Or are they both getting smaller at the same time? Are they both getting bigger at the same time? And do they seem like they're corresponding in any way? One's getting bigger and one's getting smaller, you're saying. One's getting bigger and one's getting smaller. I see that too. X looks like it's getting bigger. Does that sound right? And Y is getting smaller. And they're kind of look like they're getting related, but not like obvious. So think about it now. Do you think this would have a positive or a negative, if you recall from Tuesday's lecture, correlation coefficient? A positive or negative? And let me add to that. Do you think it will be weak, average, or strong? She's saying weak negative. She's saying a weak negative. She's saying the correlation may be there, but it's not very strong. It looks really weak. Negative because they're going in opposite directions. That's a good observation. I would go with negative because they're going in opposite directions instead of both of them going the same direction. You get it? But I think it's stronger. I don't remember what this calculates out to, but I think it's stronger than weak. What do we have to be above to be out of weak? Was it 0.25 or we agree at 0.3? I can't remember. 0.25, is that what we agreed on? Okay, well, what we agree on to be out of average and into strong, was it 0.75? 0.75, okay. Now, here it is how to let Excel calculate it. Equals CORRELL, parentheses, 1L, that's what I meant. Oh man, hang on. There you go. Parentheses, do not include the titles. Now, next week we're continuing with regression, and we will be including the titles. When I say title, that letter X. Instead, we're gonna click on the top or bottom of our data, hold down left click, drag it to the rest of our data. So now it typed C8.C16. That's where our data is at. You type a comma, and now where's the second set of data? I'm left clicking on Y8, I'm holding it down, dragging, so I let go, there's all my data, E8.E16, put my parenthesis in, here's our correlation coefficient. All that calculating we did last time, here it is. Negative 0.52, so an average. A negative 0.52137. Now, it then took that number, negative 5.2, and put it into the formula that we learned on Tuesday. Oh, did I forget to start the video, or is it going? It is going. I'm losing my mind. Equals correlation coefficient times the square root of the degrees of freedom. 9 minus 2 I put in there. I really should have used a count, where it counted how many pieces of data, and then minus 2. I just made it simple though, 9 minus 2. I want you to, the reason this is so important, you guys, I want to point this out. Look at your homework. Here's your homework for this week. You have 3 parts of your homework assignment. One is the written part that's really related to Tuesday's lecture. What we're doing right now is related to this part of your homework. Look at it, even looks the same. So every step of the way I'm showing you, but what you don't have there is you don't have the t-test formula, so you're gonna have to look at the example and figure it out. You don't have the 2-tail and 1-tail p-value formula in the spreadsheet. You gotta look at the example and figure it out, and then you gotta give me a sentence. The sentence is asking you, at 5% significance, 2-tail, can the null hypothesis be rejected, and is the correlation coefficient significant? That's what it's asking you. So you gotta give that sentence. So let me go back to this example. In this example, there it is. There's the formula that I'm using, the correlation coefficient. There's our test statistic, negative 1.6. It is a negative, so I needed to have that absolute value. Here's the 1-tail formula. Equals T, DIST, parentheses, absolute value of K10, where the negative 1.6 is, comma, 9 minus 2, or you could have just put 7 there, degrees of freedom, subtract 2, comma, and then whether it's 1-tail or 2-tail, and this one's the 1-tail, 0.075. Here's 2-tail. If it asked for a 2-tail instead, the only difference is a 2 on the end instead of a 1. Same exact formula, a 2 on the end. Look, it happens to be exactly double the 1-tail. So 0.07 is the 1-tail, 0.15 is the 2nd tail. Go ahead, Nancy.
For the
coefficient formula, does it matter which data you use first?
You know, that's a good question. I don't think it does matter. Do you want to try it the other way and see what happens?
Let's see what happens.
Yeah, okay. We're gonna try it the other way. He's saying, what if you, do the, variables in the opposite way? So here we go, I'm gonna do the y first. You know, I bet you do have to have, well, maybe not. Let's see. Now I'll do the x. What was it before? Negative 0.5? 5.2? Is that what it was? Same thing. Everything's the same. We even still get a negative t-test. We still get the 0.07, we still get the 0.15, so either one first or second.
Can you write that equation on the board?
Which equation?
Correlation.
The correlation is right here. Oh, you wanted to know what's in the parentheses, you mean? What's the parentheses? The range, is that what you're gonna call it? Range of variable 1, comma, range of variable 2, right? Now it says, at 10% significance, two-tail is the correlation coefficient significant. So we're gonna look at the two-tail, we're using 10%, you're comparing 0.15 to 10%, can we reject? When your p-value is larger than your significance, can you reject? I heard can't. This is being recorded. Listen, if you guys can just make it through today, you realize there's only 3 more lectures after this. Only 3, that's it. After we get back from vacation, there's Tuesday and Thursday, and then a Tuesday, that's the 3rd one, and then it's the final exam. So my question is, if at two-tail, 0.15, and you're comparing it to 10% significance, do we reject or not reject? Not reject, because it's larger. Larger. Since the two-tail p-value, 0.15, is greater than the significance, 0.10, we cannot reject the null hypothesis. And here, the question said, is the correlation coefficient significant? And the correlation coefficient of negative 0.52137 is not significant because we could not reject. All right, let's move on to regression. This is on page 491 from your book. This is the formula from your book. This is what it looks like on the PowerPoint using the variables. I want to point it out what this x with the line over it means. This is the mean of x. So what this formula is saying is, take each one of the pieces of data x, subtract the mean. Over here it's saying, take each one of the pieces of data y and subtract the mean of y. Then you're going to take each one of those individual answers and multiply them by each other. If there's 9 sets of data, you're multiplying 1, 2, 3, 4, 9 times. Then you add up that multiplication. That's your numerator. Now I put it in words here. The sum of, meaning added up, x minus the mean of x, y minus the mean of y. The denominator is the sum of x minus the mean of x squared. Now there's a process in doing this. I want to show you the easiest way to do this. So here's a mini example right here. 3 variables. We have 3 variables here. This is regression. And I want to find my slope. You always start with the slope. So I want to, hang on, I cheated a little. I already did the math. So I don't want to have to sit there with a calculator this whole time. So here we go. I always start with, what in the heck is the mean of x? So what we do here, 6 plus 4, switch with them. 6 plus 4 plus 2 is 12 divided by 3. So the mean of x equals 4. Does that sound right? Let me look at my notes. Yes. Here we go with y. 10 plus 6 plus 5, that's 21 divided by 3. So the mean of y equals 7. 21 divided by 3. There's our mean. We got each of them. Next step, here it is. X minus the mean of x. So I form columns just like this. I form these columns right here and I go straight across. So right here is going to be every one of my x's. 6 minus 4, 4 minus 4, 2 minus 4. What's 6 minus 4? 2. Was 4 minus 4? 0. Was 2 minus 4? Negative 2. There it is. Now I'm going to do my y minus the mean of y. So here's the column, y minus y mean. Just like this. Take each one of my y's, minus the mean of y, which is 7. 10 minus 7, 3. 6 minus 7, negative 1. 5 minus 7, negative 2. Does that sound right? There we go. Now our numerator says you take the x minus the mean of x and you multiply it times y minus the mean of y. You do each one of these. You're forming now this new column right here. So this column is going to be x minus x mean times y minus y mean. There it is. 2 times 3, 6. 0 times negative 1, 0. Negative 2 times negative 2, 4. Now I add this column. That's it. That's what the sum of means. Once you get to that point of that whole part on the numerator, you just add it. 6 plus 4 is 10. I now found the numerator. 10 divided by. All of those columns are just to find that numerator. Now the denominator, which is x minus the mean of x squared. So I'm going to form this column called x minus the x mean. X mean, and then I'm squaring it. So all I do is go back to the x minus the x mean and square each of these numbers. 2 squared, 0 squared, negative 2 squared. Add, the denominator says, add x minus the mean of x squared. So now that I have the x minus the mean of x squared, I add those up. I just found my denominator. The slope of this problem is 10 divided by 8, which is 1.25. There's the slope.
Is it 7 minus the 10 or 10 minus?
This was 10 minus 7, 6 minus 7, 5 minus 7 for all of these right here. Is that what you're asking?
Okay, I'm asking for you to subtract the 1.
Say it again.
Okay, yeah.
6 minus 4, 4 minus 4, and 2 minus 4 for this column here. So it's all the x's minus the mean of x minus the mean, and then all the y's minus the mean of y for this one. And then I multiply those two columns for the next one. So you form columns just like that. Now let me show you. Nah, I don't want to show you yet. Hang on, we're not done. We're not done. Hang on, I want to make sure. The intercept. The intercept says, take the mean of y, which is, where's the mean of y? 7. Subtract the slope, which we just calculated, 1.25. Be careful. A lot of times you get a negative slope. This would then be subtract a negative number, which would then turn into a plus. But here we go. Subtract 1.25 times the mean of x, which is 4. There is our intercept. Let me repeat. The mean of y, 7, minus the slope we just calculated, 1.25, times the mean of x. You've got to do the multiplication first. So 4 times 1.25 is negative 5. So 7 minus 5 gives you an intercept of 2. Let me check my notes. Yeah. There it is. We now have our slope and our intercept. This is how far you got to take it on the homework, regression homework Excel, which I'm about to show you an example on how to do the Excel. You got to take it this far. You got to get to the slope and you got to get the intercept. Next week, we're going to use them to make a forecast. Now let me help you see the forecast formula. Hang on. By the way, when it comes to regression, those two variables right here, one is considered what's called the response variable, and one is considered the explanatory variable. So one of these, let me for example, let's say we made one of them the price of milk, and the other one the quantity of how many units of milk we sold. So, and you wanted to predict you could go either way. You could say, I wanna predict how many gallons I'm gonna sell next week in milk, and here's what the price is gonna be. The price now would be considered the explanatory variable, because that's explaining, you're gonna use it to explain how many gallons you're gonna sell next week. The gallons then would be the response variable. But let me now turn this backwards. In business, this happens another way. You may say, oh my gosh, milk's coming in, and I've got this many units of milk coming in, and I need to sell almost all of them. I wanna plan on getting rid of them in the week. So what price do I need to set it at based on my historical sales to make sure I get rid of all of this? And then you would work it backwards. Now what you're planning on how many units of milk that you have to sell then turns into the explanatory. You're trying then to forecast what price to sell it at. That becomes the response variable, because you're using the quantity then to try to figure out what price. So whatever it is you're trying to figure out is called the response variable. I'm setting you up for a multiple choice question on the final, by the way. I gotta take that out of the video, will you, editor? All right, you had to show up for that one. Everybody get it? So you're now figuring out which is your X and which is your Y by the story. Well, the one that you were trying to forecast, if we're trying to have explained, or trying to find out what it would be in the future, is the response variable. The one that we have the information for, that we're gonna plug in as knowledge, that's the explanatory variable. All right, so now. Well, you'll have some information for it, but the response variable is the one you're forecasting in the future beyond what you have. So let's say this is our explanatory variable X, and this is our response. We have some response variables there. We're using this relationship. Now we're gonna say, okay, next month now, X is gonna be 3. We'll plug in 3 into the forecast formula, and we'll be able to forecast what Y will then end up being. So in this example now, here's the formula you haven't seen yet, that you don't have to do in your homework, but this is where we're heading to. This is the forecasting formula. The Y with the hat means your forecasted Y, whatever your response variable is, equals the intercept, which we calculated right there 2, plus the slope right there, 1.25, times the X, the thing that you're gonna use to predict. So if I said to you, hey, here's the historical X, here's our history of Y, I wanna predict Y next month. X, I know X is gonna be a 5. All we gotta do then is plug in a 5 right there. 5 times the slope, 1.25, plus 2 tells us our forecast for Y. Everybody see this? So there's our whole formula right there. Here's our forecast formula. Our forecast, which is hat Y, there it is, Y with a hat on it, equals our intercept. Now here's the weird part, this is a plus, hang on. Intercept, what am I using, V0. Plus, not minus. Yes, it's a minus on the slope formula, or on the intercept formula, but when we're doing a forecast, this is a plus here. A plus slope, which is V1, times whatever you put in for X. You're entering an X in there. Now, are you ready? Here's the tough part. We have to figure out, we want to compare this forecasting technique to another technique. Matter of fact, in business, you always try to compare 3 different forecasting techniques. And you say to yourself, okay, which one fits the data the best and is going to be the most accurate possibly in our future forecasting? You measure that by saying, let's pretend we're going to forecast 3 periods, because we have 3 periods of data here, using the X's we have here. And let's see how far off we are from the actuals. So let's say the next 3 periods, we're gonna be a 6, a 4, and a 2. We'll put in a 6 there, calculate a forecast. We'll put a 4 there, calculate a forecast. We'll put a 2 there, calculate a forecast. And we'll compare them to the 10, the 6, and 5. And the difference is called the residual. Someone. Oh, right there. There it is. the residual. Actual minus the forecast. And that residual is used in different measurement tools to decide how well the forecasting technique is fitting the data. Here's an example. If we had, we're going back to this right here. Let me show you something. Is this it? Remember this from Tuesday? There was debt payments for these 26 cities. There was their income. We found there was a relationship between income and debt. Well, let's say we wanted to forecast what maybe income is in a city, what the average income is, or we want to forecast what the monthly debt payments would be in a city. We could use one of these numbers and forecast the other number. So there's all the data right there. What you see, that line going through the middle, that is what you would use then to forecast. Now, this is SSE. This is the sum of the squares error. And that's also used in calculating the fit of a forecasting technique to the data that we're going to go into next week. So let's look again for this week. Here it is. Pretend you have all of this data, X and Y. X is going to be the explanatory data, Y is going to be the response data. Now look at what I did. I started forming the same columns you see up here, but with a lot more data. So right here, X minus the mean of X, I'm just taking C8 minus E minus, what is it? Minus C20, oh, the mean, minus C21. Here's the mean. I use the Excel average. Now, I want you to look at this spreadsheet, and I want you to look at your homework spreadsheet. Whoops, not that one. This one. Everybody see it? This is your homework. Time, month 1 through 15, is the explanatory. Sales is the response. You're going to be asked to do those same calculations, all of these columns, just like this, on your regression spreadsheet, and get to the point of where you're calculating the slope and the intercept. So you got to do these columns. Here's your columns right here. 1, 2, 3, 4 columns. And you're using these numbers right here to get your slope and your intercept. And that's all it's asking for on this spreadsheet. But it's all done on the spreadsheet. And then you hand in the spreadsheet. Same as the correlation spreadsheet. You're handing that in as a spreadsheet also. The only handwritten problem you have is that written one from Tuesday's lectures. All right, let's go back to the example so you're getting how to do this. I want to make sure everybody gets this. So here's my X minus the mean of X, taking each one of these numbers, C8 minus C21, whoops, C9 minus C21, C10 minus C21. By the way, let me show you an easier way to do this. I should have put a $ in front of that C right there and a $ in front of that 21, then just copy paste. The C21 would stay the same on all the cells below it, and only the first cell would have changed. I don't know why I did this a long time ago, maybe. Okay, here's now Y minus the mean of Y. 32 minus 26 point, or cell, what is that? Cell E8 minus E21. Cell E9 minus E21. Cell E10, notice the mean is being subtracted from each one of those. The next column, this is the X minus the mean of X times Y minus the mean of Y. I'm taking column H times column J. H8 times J8. H9 times J9. H10 times J10, and so on and so on. And then I added that whole column. There's my numerator. Just like 10 was our numerator here, that column right there, the sum of it is the numerator there. And if you look down here, that's what I'm using to find the slope right here. So this numerator should be L21. So if I click right here in this cell, the slope should be using L21 divided by, there it is, L21 divided by H37, which is this column. Here it is. X minus the mean of X, this last column right here, X minus the mean of X, and then it's squaring each number. It's just going to the column for x minus the mean of x, which is h8, h9, h10, and squaring each one of them. And then adding up those squares, and there's your denominator. And for this example, the slope was negative 6.68. How would you describe this slope, negative 0.68? This, I'm sorry, not slope. Forget what I just said. I thought it was a correlation coefficient and mixing it up. Now, to get the intercept, you're gonna have to use the mean of y, the mean of x, and the slope you just calculated. So here it is. E21, which is, where's E21? Which is the mean of y, minus C24, which is the slope right here, times C21, which is the mean of x. That's as far as you gotta take it. You gotta take your spreadsheet before December 3rd, before December 3rd, and make sure and put in a formula that finds the intercept and the slope using the numbers after you form your columns. Does everybody understand what's expected in this homework spreadsheet? Everybody knows what's expected in the other spreadsheet? Everybody's got it? All right. The only thing I skipped that I want to make sure and cover is this standard, the sum of the squares error, SSE. Basically, when we get to this point, you're making one more column. It's the y minus the mean of y squared. So I want to show you that. And then you would add it up. I'm sorry, y minus the forecast y. So we're going to have to plug this in for each number. Ready? Plugging in a 6. The intercept is 2. The slope is 1.25. What do we get for this one? I think I got it right here. This would be 6 times 1.25 plus 2 ends up being 9.5. Now, we just used 6. That was an actual number from the data. And we have an actual result when we're using 6. So now we can compare what we would have forecasted at 9.5. How far off are we? Now look at the formula that says take the actual minus the forecast, then square it. So here we go. This is going to be the actual 10 minus the forecast, 9.5, which equals 0.5, then square it. Equals 0.25. There's the first one. Next, I'm plugging in another number we have, 4. Plug in 4 in for x times 1.25 plus 2. It's x times the slope plus the intercept. This happens to equal -1. No, I'm sorry, not -1, 7. 7. Now, when we actually had 4 as x, our result was a 6. So is our forecasting technique on? Well, when we put 4 into the formula, we get a 7. So we take the actual 6 minus the forecast 7, and we get -1. Then we square it, and we get 1. There's the second one. We got one more number to do. The 2 is our intercept we calculated right here, that you have to add every time into the forecasting technique, because it's that intercept plus that slope we calculated, 1.25, which is right here. And then we'll just keep plugging x's in, actual x's that we have. One last x we have to do is a 2. So I'm going to plug a 2 in times 1.25 plus 2. 2 times 1.25 is 2.5 plus 2 equals 4.5. Let me check my notes, see if that's right. 4.5. The actual was a 5, so now we have 5 minus 4.5 equals 0.5. Now we square it equals 0.25. We add this together. This is the last step. It says take every actual result for y minus every forecast for that y, then square each one, now add them up, and this is our SSE, which we're going to work with next week. 1 plus 0.25 plus 0.25 is 1.5 SSE. sum square error. That's one of the error techniques we're gonna use to figure out if this fits or not. By the way, that's a pretty good fit. That's a pretty low. The lower the better. That's the thing you gotta remember. The lower the better. The lower that is, the better. You're gonna calculate an SSE with a different forecasting technique. And this way you can compare apples to apples. When you break it to an SSE, whichever one's lower is fitting the data better. And then you use it to forecast the future. Are you ready to do your own forecast? The lower the SSE, the better the fit is of the forecasting technique to the data. The better the fit. And you want that SSE to be as low as possible for the technique you're gonna use to forecast.
Do we need to know all this right now?
Maybe. Let's take a look, let's read this and see. You see right now you need to do this in class?
No, are we doing this again? After break?
We're doing some of this again after break. Yes, this SSE definitely, yes. The forecasting, yes. Yeah, we'll do this again. What break are we talking about? There's a break? You ready? Consider the following hypothesis. The correlation coefficient greater than or equal to 0 is your null hypothesis. Your alternative hypothesis, correlation coefficient is less than 0. One tail or two tail? Very good. A sample consists of 30 observations, and a sample correlation coefficient is negative 0.46. Show your calculation details to calculate a test statistic, and give the Excel equation to find the critical value. Then explain if you can or cannot reject the null hypothesis using the results. Use 1% significance. Good luck. This is one of those I'm not here for. This is your second to last in-class assignment. You only have 2 left. This one and one other. That's it.